Hello, how you doing? This is Mike here, and in this section we are going to talk about our hyperbolic functions. Our hyperbolic functions. And some of you may have heard these before, and they're very interesting. It's a very unique way. So these are a very unique way of relating trigonometric functions with exponential functions. So a lot of people, I know when I was going through this course originally, that I never saw the original relationship that occurs between trigonometric functions and then some exponential functions, but it's actually very surprising. You see them in a lot of engineering applications, very common in engineering applications, but the relationship within the context doesn't really always expose itself until you start investigating more advanced complex values. So in this section, we're just going to go ahead and define our hyperbolic functions and how we can express them. So the first thing that we want to do is we are going to redefine e to the x. And we can redefine e to the x as e to the x plus e to the negative x, and this is all divided by 2. And then we're going to add e to the x minus e to the negative x all over 2. So be very careful. This is almost the exact same thing. However, it differs by the sign between the two exponential functions. So this is actually a combination of an even function, and this guy over here is an odd function. So it's actually the way that we can relate e to the x in terms of a little of a breakdown to make a little bit easier for us to see the definitions of our hyperbolic functions. So the odd function, so this odd function, which I guess we'll tackle this odd function first. So this odd function is a really interesting guy, and he's a little bit different because I know a lot of times we're thinking, we're thinking of trigonometry, and we're thinking of our even or odd functions, and it's not exactly the same thing. So let's go ahead and define hyperbolic sine, and this is, I'm sorry, sine. This is going to be abbreviated sinh. This is enunciated sinh, not sine h, sinh. So hyperbolic sine is sinh. And this is going to be equal to e to the x. Oh, I just lost part of my work there, all over 2. So let me go ahead and rewrite this here. So that was this portion right here. So hyperbolic sine is denoted as sinh, and this guy is the odd function. And we'll talk about why he is odd in a little bit, but right now I just want to make sure that we understand that he is the odd function. The even function is going to be hyperbolic cosine. And this is abbreviated cosh. So this is cosh, sinh and cosh. And this will be equal to the first value, e to the x plus e to the negative x all over 2. And cosh happens to be the even function. And once we graph these, I think these will be a little bit easier for us to see than just memorizing whether even or odd. But right now we're starting to look a little patriotic. So let's go ahead and cover the rest of our hyperbolic functions so we know what they are. So we've covered sinh and cosh. Now we're going to have hyperbolic tangent. So hyperbolic tangent. This guy is equal to, this guy is tanh. So it's tangent h, tanh is the way that we announce him. And hyperbolic tangent is going to be the very similar relationship to our normal tangent function. It's going to be sinh, it's going to be sinh over cosh. So if we take sinh, it's a little bit complex to say, and we divide him by cosh, then we see that we are left with the 2's cancel. So we're left with e to the x minus e to the negative x all over e to the x plus e to the negative x. And that's the reason why. Once we get our sinh and our cosh, the rest of these should come pretty easily. So hopefully we know that hyperbolic, we can see the relationship now of hyperbolic cotangent. This hyperbolic cotangent is cosh. This is going to be cosh all over sinh. This is a word to say. I've never had problems saying it before. Oh no, I just lost. Ah, that's horrible. So I just lost. So what was I doing here? So this was cosh. Sorry about this. My program just wants to start erasing things on me. So this will be equal to e to the x plus e to the negative x all over 2. And this will be divided by e to the x plus e to the negative x all over 2. So this, oh wait, I think, oh, I missed that one, sorry. This sinh is actually minus. So this will be e to the x minus e to the negative x. Sorry, my program keeps erasing things. So this will just be the inverse. So this will be the inverse of tan. So this will be e to the x plus e to the negative x all over e to the x minus e to the negative x. So that defines cosh, not kosh, cosh. So, or you could just say hyperbolic cotangent. I tend to do that with hyperbolic cotangent and hyperbolic cosecant. So I just have I have an issue saying those for some reason, but that's just me. So now hopefully you guys can maybe even try to derive hyperbolic secant and hyperbolic cosecant. This is sech. Some people say sech. I say sech, and this is cosech. This is cosech. So oops, C-S-C-H. Some people say sech. I say sech. I just get in the habit of just saying hyperbolic secant, hyperbolic cosecant. It just makes it a little bit easier for me. So this is going to be 1 over cosh, and that's going to be, excuse me, that's going to be 1 over cosh, and if we recognize that 1 over cosh is going to be the inverse of cosh, which is going to be 2 all over e to the x plus e to the negative x, and hyperbolic cosecant is going to be 1 over sinh, and this will be equal to the inverse of sinh, which is going to be e to the x minus e to the negative x. Let's say we get that there, minus e to the negative x. Oh no, I'm not going to rewrite all that. Hopefully we got that in their notes. Oh, that's just so annoying. That's just so annoying. So this is going to be 1 over cosh, 1 over sinh. There we go. Hopefully I got that all back. So these will be our hyperbolic functions. So I apologize for the computer erasing my work there. That's very annoying. So let's go ahead and just try a simple example. Let's just try a simple example. Let's go ahead and identify sinh of 0. So I'm going to write this sinh of 0. So I like to just write out my hyperbolic functions. It makes it easier for me. I know sinh is going to have a subtraction value, so I'm just going to have e to the 0 minus e to the negative 0 all over a value of 2. E to the 0 is going to be a value of 1. If we look at this, we're going to have e to the negative 0, which is the same as e to the 0. So we're going to have minus 1 all over 2. This gives you a value of 0. So hyperbolic sine of 0 is equal to a value of 0. Relatively easy. I think this is very, very nice to work with. I really enjoy my hyperbolic functions. So let's see how we do here. Let's go ahead and try cosh of 0, and then maybe let's go and try sinh of 2. So if you want to pause this and try to work that out, that might help. And hopefully you're back now. So cosh is going to be e to the 0 plus e to the negative, e to the negative 0 all over a value of 2. This gives us 1 plus 1 all over 2. And this gives me a value of 1. So cosh of 0 is equal to 1. And now sinh will give me e to the second power plus, minus e to the negative 2 all over a value of 2, and you're just going to have to plug this in the calculator. I think this comes out to be approximately 3.6. 3.6. You could leave it just like this. On any exam, if it came to working with your hyperbolic functions, you're more than welcome to leave it like this. You don't have to use a calculator to calculate it out. So these are our basic definitions. There are going to be some very important relationships and identities that we're going to use, as well as some derivative and integral rules with our hyperbolic functions. So hopefully when you rewatch the next videos, you'll be able to see those.